Welcome to our channel. Today, we're going to explore one of the most critical aspects of any organization, quality. In this video, we'll be diving into the world of quality assurance and control and demystifying the differences between these two often confused terms. Quality assurance, QA, and quality control, QC, are two related but distinct concepts that are essential for ensuring the quality of products, services, or processes. But what's the difference between them? Is QA just QC with a fancy name? Are they interchangeable terms? In this video, we'll explore the key differences between QA and QC, including their focus, timing, scope, and goals. We'll also delve into the importance of quality standards, policies, and procedures, and how they relate to QA and QC. Whether you're a quality assurance professional, a business owner, or simply someone who wants to understand the importance of quality in your organization, this video is for you. So, let's get started. Quality assurance, QA, and quality control, QC, are two related but distinct concepts in the context of product development, manufacturing, and service industries. While they are often used interchangeably, there are significant differences between the two. Quality assurance, QA. Quality assurance is a proactive process that focuses on preventing defects and ensuring that products or services meet the required standards, specifications, and regulations. QA is concerned with ensuring that the entire product development process, from design to delivery, meets the required quality standards. QA activities aim to establish quality policies and procedures, develop and implement quality plans and objectives, conduct regular audits and assessments to identify areas for improvement, provide training and awareness programs for employees, monitor and control the quality of processes and systems. QA is a proactive approach that focuses on building a culture of quality into every aspect of an organization. It's about designing and implementing processes, procedures, and systems to ensure that products or services meet specific standards and requirements before they are released. QA aims to prevent defects from occurring in the first place, rather than just detecting and correcting them after they've already happened. In other words, QA is about being proactive and anticipatory, identifying potential issues early on and taking corrective action to prevent them from becoming major problems. This approach helps to reduce errors, improve efficiency, and enhance customer satisfaction. While quality control, QC, is a reactive process that focuses on detecting and correcting defects or nonconformities in products or services after they have been produced or delivered. QC is concerned with identifying and addressing defects or errors that have occurred during the production process. QC activities aim to conduct inspections, testing, and evaluations to detect defects or nonconformities, identify the root cause of defects or errors, take corrective action to rectify defects or errors, implement corrective actions to prevent recurrence. On the other hand, QC is a reactive approach that focuses on detecting and correcting defects after they have already occurred. It's about inspecting and testing products or services to identify any deviations from standards or requirements, and then taking corrective action to fix the issues. QC is often seen as a last resort, as it can be more costly and time-consuming to fix defects after they've already been introduced into the process. QC can also lead to a culture of fixing the problem after the fact, rather than preventing problems from happening in the first place. Key differences. 1. Focus. QA focuses on preventing defects, while QC focuses on detecting and correcting defects. 2. Timing. QA is proactive, happening before production or delivery, while QC is reactive, happening after production or delivery. 3. Scope. QA encompasses the entire product development process, while QC is limited to detecting defects in the finished product. 4. Goals. QA aims to ensure compliance with standards and regulations, while QC aims to identify and correct defects. Quality assurance is a broader concept that emphasizes prevention and continuous improvement, while quality control is a more focused concept that emphasizes detection and correction of defects. Both are essential components of a comprehensive quality management system. To illustrate the difference, think of QA as building a strong foundation for your house, while QC is like repairing cracks in the walls after they've formed. QA is more effective in preventing problems, while QC is more reactive and focused on fixing problems after they've occurred. As a quality assurance, QA officer, developing quality standards is a critical function that ensures the organization meets regulatory requirements and industry best practices. Here's a step-by-step guide on how to develop quality standards, policies, and procedures. To begin, you need to review regulatory requirements, such as FDA, ISO, or industry-specific guidelines, to get familiar with them. Research industry-recognized standards, guidelines, and benchmarks to discover the best practices and areas for improvement in your industry. Determine what your organization's quality objectives and priorities are, such as ensuring product quality, meeting customer satisfaction, or increasing process efficiency. Implement a quality management system, QMS, that aligns with your organization's objectives and regulatory requirements, including documenting policies, procedures, and processes. Based on your QMS, develop quality standards that outline the specific requirements for your products, services, or processes. These standards should be specific, measurable, achievable, relevant, and time-bound, SMART. Develop policies that provide clear guidance on how to achieve the quality standards and make sure they are easy to understand for all stakeholders. Create step-by-step procedures that outline the actions to take to achieve the quality standards and policies. Procedures should be detailed, step-by-step instructions that are easy to follow. Identify any gaps between your current processes and desired quality standards and develop a plan to address these gaps and implement corrective actions. Provide training to personnel on the new quality standards, policies, and procedures to ensure they understand and comply with them. Regularly monitor and evaluate the effectiveness of your quality standards, policies, and procedures to identify areas for improvement and make necessary adjustments. Continuously review and update your quality standards, policies, and procedures to reflect changes in regulatory requirements or industry best practices. Additional tips. Throughout the development process, it is essential to involve stakeholders to guarantee that their needs are considered and integrated into the project. Using templates or existing documents as a starting point can significantly reduce the time and effort required for development, allowing for more efficient project management. Clear and concise language is crucial to avoid any confusion or misinterpretation, making it necessary to keep the content simple and easy to understand. It is vital to ensure that all documents are easily accessible to personnel who need them, promoting seamless communication and collaboration throughout the project. Maintaining a thorough record of all development activities, including changes, revisions, and approvals, is essential for tracking progress, identifying areas for improvement, and ensuring accountability. While QA focuses on developing quality standards, policies, and procedures to ensure compliance with regulations and industry standards, QC is primarily concerned with inspecting products or processes to ensure they meet those quality standards. Think of QA as setting the benchmark for quality, while QC is responsible for checking whether the products or processes meet those benchmarks. To illustrate the difference, let's look at our two step-by-step guides. The QA guide covers developing quality standards, policies, and procedures for an organization, whereas the QC guide outlines a step-by-step process for conducting product inspections in manufacturing. In QA, we focus on setting standards for product quality, customer satisfaction, and process efficiency. We develop policies and procedures to ensure that our organization meets those standards. In QC, we inspect products or processes to ensure they meet those same standards. For example, QA might develop a policy for product testing, while QC would be responsible for actually conducting those tests and ensuring that the products meet the required specifications. By combining both QA and QC efforts, organizations can ensure that their products or services meet both internal quality standards and external regulatory requirements. Here's a quality control step-by-step guide for product inspection in manufacturing. Review relevant regulatory requirements. Examples: ISO 17025. FDA regulations. Research industry recognized standards and guidelines for product inspection. Examples: ASTM, ANSI. Identify the purpose and scope of product inspection. Determine the types of defects or nonconformities to be inspected. Establish priority levels for inspections based on product criticality and risk. Develop step-by-step procedures for conducting inspections, including sampling plans and sampling frequencies. Define the criteria for acceptance or rejection of products. Identify the personnel responsible for conducting inspections and their qualifications. Perform regular inspections of products to ensure compliance with specifications and standards. Identify defects or nonconformities and document findings. Implement corrective actions for defects or nonconformities. Maintain accurate records of inspections, including results and corrective actions. Document all defects or nonconformities found during inspections. Track the effectiveness of corrective actions implemented. Regularly review inspection results to identify trends and areas for improvement. Analyze data to evaluate the effectiveness of inspection procedures and identify opportunities for improvement. Continuously review and update inspection procedures to reflect changes in regulatory requirements or industry best practices. Review inspection results to identify trends and areas for improvement. Implement changes to inspection procedures as necessary to maintain compliance with regulatory requirements and industry standards. Train personnel on updated procedures to ensure seamless implementation. Key differences between QA and QC. 1. Purpose. QA focuses on ensuring quality throughout the entire product development lifecycle, from design to delivery, while QC focuses on ensuring quality at the point of production or inspection. 2. Scope. QA encompasses a broader range of activities, including design, development, testing, and maintenance, while QC is focused specifically on inspecting products during production. 3. Objectives. QA aims to prevent defects or errors by identifying and addressing them early in the development process, while QC aims to detect defects or nonconformities during production. 4. Methods. QA uses various methods such as testing, audits, and reviews to ensure quality, while QC uses inspection methods such as sampling plans and acceptance criteria. As a quality assurance officer, maintaining accurate records and documentation is a crucial aspect of your role. Establish a document control system. Set up a centralized document control system to store, manage, and maintain all quality assurance-related documents. This can be an electronic document management system, EDMS, or a physical filing system. Define document templates. Create templates for frequently used documents such as test protocols, test reports, deviation reports, and corrective action reports. This will ensure consistency in documentation and reduce errors. Assign responsibilities. Clearly define roles and responsibilities for document creation, approval, and maintenance. Ensure that each person involved in the process understands their responsibilities. Track changes. Establish a change control process to track changes to documents, including version control and approval procedures. Retain records. Retain records for the required period, as specified in your quality management system, QMS, or regulatory requirements. Review and update. Regularly review and update documents to ensure they remain relevant and accurate. Training and awareness. Provide training to all personnel involved in documentation management on the importance of accurate documentation, document control procedures, and record retention. Access control. Implement access controls to ensure that only authorized personnel can access and modify documents. Document retrieval. Establish a process for retrieving documents quickly and efficiently when needed. Auditing and compliance. Conduct regular audits to ensure compliance with regulatory requirements and internal procedures. Key documents to maintain accurate records. Test protocols. Detailed descriptions of test procedures, including test methods, equipment, and sampling plans. Test reports. Reports summarizing test results, including any deviations or nonconformities found. Deviation reports. Reports documenting deviations from standard operating procedures, SOP, or specifications, including investigation results and corrective actions taken. Corrective action reports. Reports documenting the root cause analysis and corrective actions taken to address deviations or nonconformities. Change control records. Records documenting changes made to products, processes, or procedures, including the reason for the change and any impact on quality. Calibration records. Records documenting calibration of equipment, including dates, calibration results, and any necessary corrections. Tips for maintaining accurate records. 1. Use legible handwriting or clear printing when filling out forms. 2. Use standardized templates and formats to ensure consistency. 3. Verify accuracy before submitting documents for review or approval. 4. Retain all original records in a secure location. 5. Maintain a record of all changes made to documents. The quality control, QC, process focuses on ensuring that the products or processes meet the required quality standards. QC documentation provides a comprehensive record of the quality control activities, including inspections, testing, and corrective actions. The purpose of QC documentation is to provide a clear and transparent account of the quality control process, enabling the identification of defects, nonconformities, and areas for improvement. The QC documentation includes records of material reviews to identify defects, damage, or nonconformities in materials and components. Regular inspections and testing of products or processes to ensure compliance with quality standards. Defect identification and reporting to relevant personnel. Corrective actions taken to address defects or nonconformities. Performance monitoring and analysis to identify areas for improvement in production processes. Scrap and rework management to minimize waste and improve efficiency. Process validation to ensure production processes meet quality standards. Supplier quality management to ensure suppliers meet quality requirements. Continuous improvement initiatives to reduce defects, improve efficiency, and increase customer satisfaction. Compliance monitoring. This document ensures that the organization is adhering to regulatory requirements and industry standards. It involves regular monitoring of compliance and reporting any non-compliances to relevant authorities. Specifications. These documents define the requirements for a product or process, providing a clear understanding of what is expected. They serve as a reference point for quality control activities, such as inspection and testing. Control charts. These charts track and monitor product or process performance over time, enabling the identification of trends, patterns, and anomalies. They help quality control personnel to take corrective action before defects or nonconformities occur. Process control procedures. These procedures outline the steps to be followed to control a process, ensuring consistency and repeatability. They provide a roadmap for quality control personnel to follow during inspections and testing. Inspection and test plans. These plans outline the inspections and tests to be performed on products or processes, ensuring that all necessary checks are completed and documented. Sampling procedures. These procedures outline the methods used to collect samples for testing or inspection, ensuring that samples are representative of the product or process being monitored. Acceptance criteria. These documents define the criteria for accepting or rejecting products or processes, providing a clear understanding of what constitutes compliance with quality standards. Key differences between QA and QC. QA focuses on ensuring that the processes and procedures are in place to ensure quality, whereas QC focuses on monitoring and controlling the quality of products or processes. QA is more focused on documentation and record keeping, whereas QC is more focused on inspection and testing. QA is concerned with preventing defects, whereas QC is concerned with detecting and correcting defects. As a quality assurance officer, identifying opportunities for process improvement is crucial to enhance product quality, efficiency, and cost-effectiveness. Here's a step-by-step approach to help you. Identify opportunities for process improvement. 1. Understand the process. Familiarize yourself with the current process, including its purpose, inputs, outputs, and stakeholders. Document the process flowchart or map to identify the various steps involved. 2. Identify key performance indicators, KPIs. Determine the metrics that measure the process's effectiveness, such as cycle time, defect rate, customer satisfaction, or cost. Analyze these KPIs to identify areas for improvement. 3. Analyse data. Collect and analyze data on the process, including process metrics, examples, cycle time, defect rate, customer feedback, examples, surveys, complaints, employee feedback, examples, suggestions, concerns, regulatory requirements. 4. Conduct observations. Observe the process in action to identify inefficiencies, waste, and bottlenecks. Take notes on workarounds, inconsistent application of procedures, variability in output quality, employee stress or frustration. 5. Interview stakeholders. Talk to employees involved in the process, customers, and other stakeholders to gain insights on pain points and challenges. Suggestions for improvement. Gaps between expected and actual performance. 6. Root cause analysis. Identify the root causes of problems and inefficiencies using tools like fishbone diagram, Ishikawa diagram, SWOT analysis, or strengths, weaknesses, opportunities, threats analysis. 5. Whys analysis. Start by stating the problem. Why did this happen? Get an initial answer, which may seem like the cause, but is often just a symptom. Ask why again to get more information. Continue asking why for more times, each time trying to get closer to the root cause. By the 5th why, you should have identified the underlying root cause of the problem. 7. Prioritize opportunities. Based on the analysis, prioritize opportunities for improvement by considering impact on product quality or customer satisfaction, cost savings or revenue potential, ease of implementation, alignment with organizational goals. 8. Develop improvement ideas. Generate potential solutions for each opportunity, considering process changes, example, new procedures, reorganization, technology advancements, example, automation, software updates, training or development programs. 9. Evaluate and refine ideas. Evaluate each idea against criteria like feasibility, cost-effectiveness, and potential impact. Refine ideas based on stakeholder feedback and further analysis. 10. Implement and monitor changes. Implement the chosen improvements and monitor their effectiveness through data analysis, stakeholder feedback, audits or inspections. 11. Continuously improve. Regularly review and refine processes to ensure they remain effective and efficient. Remember to communicate changes to stakeholders throughout the process improvement journey and involve employees in the improvement process to ensure ownership and engagement. Additional tips. Focus on continuous improvement rather than one-time fixes. Involve cross-functional teams to ensure a holistic understanding of the process. Celebrate successes and learn from failures. Document lessons learned to apply to future improvements. QC step-by-step approach to identify opportunities for process improvement. 1. Pre-production checks. Inspect raw materials and components for defects or irregularities. Verify that products meet specifications and standards. 2. In-process inspections. Monitor production process to detect defects or deviations. Take corrective action to prevent defects from occurring. 3. Final inspections. Inspect finished products for defects or nonconformities. Verify that products meet customer requirements and specifications. 4. Testing and validation. Conduct testing to verify product performance and functionality. Validate products against industry standards and regulations. 5. Defect tracking and reporting. Identify and track defects or nonconformities. Report defects to production teams for corrective action. 6. Corrective action. Implement corrective actions to address defects or nonconformities. Verify effectiveness of corrective actions. Key differences between QA and QC. Focus. QA ensuring product quality and reliability, while QC ensuring product meets customer requirements and specifications. Scope. QA involves identifying areas for improvement in processes and systems, while QC involves inspections, testing, and validation of products. Goals. QA prevent defects, ensure quality, and maintain product reliability, while QC improve processes, reduce errors, and enhance customer satisfaction. Methods. QA analysis, root cause analysis, prioritization of opportunities for improvement, implementation of changes, while QC inspections, testing, validation, defect tracking, and reporting. Tools. QA quality manuals, checklists, inspection forms, while QC process flowcharts, KPIs, data analysis tools, stakeholder feedback tools. Note that QC is focused on ensuring the quality of the product itself, while QA is focused on ensuring the quality of the processes and systems that produce the product. Risk assessment is a crucial part of QA role to identify, evaluate, and mitigate risks associated with product quality, safety, and compliance. Here's a step-by-step guide on how QA to conduct a risk assessment. Step 1. Identify the risks. Identify potential hazards and risks that could impact product quality, safety, and compliance. Review internal and external data such as product specifications and design documents, manufacturing and testing processes, customer feedback and complaints, industry trends and competitor analysis. Step 2. Categorize and prioritize risks. Prioritize risks based on their likelihood and impact. High risk. Potential harm or damage to people, environment, or property. Medium risk. Potential damage to reputation or financial losses. Low risk. Potential minor inconveniences or annoyances. Step 3. Analyze risks. Assess each risk using the following criteria. Likelihood. How likely is the risk to occur? Impact. What would be the consequences if the risk occurs? Vulnerability. How vulnerable is the organization to the risk? Control measures. Are there existing controls in place to mitigate the risk? Step 4. Develop mitigation strategies. Based on the analysis, develop strategies to mitigate each risk. Implement new controls or modify existing ones. Improve training programs for employees. Develop procedures for emergency response and crisis management. Communicate risks and mitigation strategies to stakeholders. Step 5. Monitor and review. Continuously monitor and review the effectiveness of the mitigation strategies. Track key performance indicators, KPIs, and metrics. Conduct regular audits and assessments. Update mitigation strategies as needed. 15 QA different risk assessment tools commonly used in various fields such as business, engineering, healthcare, and finance. 1. failure mode and effects analysis, FMEA. A systematic approach to identify potential failures in a process or system and their impact on quality. 2. Fault tree analysis, FTA. A top-down approach to identify potential failures by tracing back from a desired state to all possible causes of failure. 3. Event tree analysis, ETA. A methodology that differs from fault tree analysis, FTA, in its focus. While FTA identifies the possible combinations of events that can lead to a failure, ETA examines the sequence of events that can ultimately result in a specific outcome or failure. ETA adopts a bottom-up approach, analyzing the series of events that can culminate in a particular outcome or failure. 4. Hazard and operability study, HAZOP. A structured approach to identify hazards and operability issues in a process or system. 5. SWOT analysis. A strategic planning technique to identify strengths, weaknesses, opportunities, and threats related to a project or organization. 6. Risk matrix. A simple table that plots risks against their likelihood and impact to help prioritize them. 7. Pareto analysis. A method to identify the most critical factors contributing to a problem or risk. 8. Design of experiments, DOE. A statistical approach to identify the most critical factors affecting a process or outcome. 9. 6 thinking hats. A decision-making technique that helps identify risks from different perspectives. 10. Risk register. A document that records and tracks risks throughout a project's life cycle. 11. Ono circle. A problem-solving approach that involves identifying the root cause of a problem and implementing corrective actions. 12. Root cause analysis, RCA. A method to identify the underlying causes of a problem or risk. 13. Fishbone diagram, Ishikawa diagram. A visual tool to identify the possible causes of a problem by brainstorming ideas. 14. Risk scoring. A method to quantify the likelihood and impact of risks using numerical values. 15. Hazard analysis critical control points, HACCP. A food safety system that identifies critical control points in food production. Note that some tools and strategies may overlap between QA and QC. QC focuses specifically on identifying and mitigating risks that could impact product quality, whereas QA focuses on ensuring overall product quality. And evaluation criteria. 2. Conduct needs assessment. Conduct a needs assessment to identify the knowledge gaps and skill deficiencies of employees in quality assurance processes, standards, and tools. This will help you tailor the training to meet specific needs. 3. Provide standard operating procedures, SOPs. Develop and provide SOPs that outline the quality assurance processes, procedures, and standards for employees to follow. Ensure that SOPs are easy to understand, concise, and accessible. 4. Hands-on training. Provide hands-on training sessions to demonstrate the use of quality assurance tools, software, and equipment. This will help employees understand how to apply the tools and technologies in their daily work. 5. Classroom training. Conduct classroom training sessions to provide theoretical knowledge on quality assurance principles, regulations, and standards. Use visual aids, case studies, and group discussions to engage employees. 6. Online training. Offer online training modules or webinars to supplement classroom training. This will help employees access training materials at their convenience and reduce costs. 7. Coaching and mentoring. Provide coaching and mentoring to employees who require additional support or guidance on quality assurance processes and standards. 8. Feedback mechanism. Establish a feedback mechanism to collect feedback from employees on the effectiveness of the training program. Use this feedback to improve the training program and address any concerns or issues. 9. Continuous monitoring. Continuously monitor employee performance and knowledge levels to ensure that they are adhering to quality requirements. 10. Recognition and rewards. Recognize and reward employees who demonstrate excellent performance in quality assurance processes and standards. 1. Quality management principles. What are the fundamental principles of quality management? How do these principles apply to everyday work? 2. Quality control processes. What are the steps involved in quality control processes? How do these processes ensure product quality? 3. Quality assurance standards. Example ISO 9001. What are the key elements of ISO 9001? How do these standards impact daily work? 4. Regulatory requirements. Examples: FDA, GMP. What are the key regulations and guidelines for quality assurance? How do these regulations impact daily work? 5. Auditing techniques. What are the different types of audits? How do auditing techniques ensure quality compliance? 6. Document control and record keeping. Why is document control important for quality assurance? How to properly maintain records and documents. 7. Corrective action and preventive action, CAPA, process. What is the CAPA process? How does it help improve quality? 8. Root cause analysis, RCA. What is RCA and why is it important? How to conduct an RCA investigation. 9. Continuous improvement methodologies, example, Kaizen. What is Kaizen and how does it promote continuous improvement? How to apply Kaizen principles in daily work. 10. Employee empowerment and involvement in quality improvement. Why is employee involvement important for quality improvement? How to empower employees to take ownership of quality improvement. Training methods. 1. Classroom instruction. A traditional method where trainers teach employees in a classroom setting. 2. On-the-job training. A hands-on approach where employees learn by performing tasks under supervision. 3. Online modules or webinars. And online training sessions that can be accessed remotely. 4. Coaching and mentoring. A one-on-one guidance and support from experienced professionals. 5. Workshops or seminars. And interactive training sessions that encourage discussion and participation. 6. Case studies and group discussions. A real-life scenarios used to illustrate concepts and encourage discussion. 7. Role-playing exercises. Simulated scenarios that mimic real-life situations to practice skills. 8. Simulations. A computer-based simulations that mimic real-world scenarios to practice skills. 9. Quizzes or assessments. Evaluations that test knowledge and understanding. 10. Gamification. Example, gamified training platforms. And interactive training platforms that use game-like elements to engage employees. Create scenarios that simulate real-world situations, such as responding to a customer complaint or investigating a product defect. Then learners must make decisions and take actions to resolve the scenario, earning rewards or penalties based on their choices. And that's a wrap. We've covered the essential roles of quality assurance and quality control and how they work together to drive success in your organization. Whether you're a quality professional or just starting out, I hope you found this video informative and helpful. As you've learned, QA is all about being proactive, identifying areas for improvement, and implementing measures to prevent defects. QC, on the other hand, is about being reactive, detecting errors, and taking corrective action to prevent recurrence. Now, we'd love to hear from you. Do you have any additional insights or experiences with QA and QC that you'd like to share? Have you found any effective strategies that work in your organization? Please feel free to comment below and share your thoughts. Your input can help others who may be facing similar challenges, and who knows, it might even spark new ideas for our future videos. Thanks again for watching, and we'll see you in the next video.